Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today we are mastering LeetCode 73. Set matrix zeros. This is a classic grid manipulation challenge that tests your ability to optimize space. Let us look at the problem statement. We are given an m by n integer matrix. If an element is 0, we must set its entire row and column to zeros. But here is the catch, we must do it in place. No extra matrices, no extra space. Think of it like a security lockdown protocol. If a single room in a corridor is compromised, the entire corridor must be sealed. But we cannot just start sealing as we go, or we might accidentally seal a room that was perfectly safe. We need a way to mark the corridors first, without using extra memory. Now, for our strategy. We use the first row and the first column of the matrix itself as our markers. First, we check if the first row or column already contains a 0. We save those as simple flags. Then, we scan the rest of the matrix. If we find a 0 at index 1, j, we mark the start of its row and column by setting matrix I, 0, and 0, j, to 0. Finally, we use these marks to seal the entire grid. Time complexity? O of m times n space complexity? O of 1. Let us dive into the dry run. Look at the screen. We have a 3x4 matrix. First, we check our special flags. Does the first row have a 0? No. Does the first column have a 0? No. We save these as false. Now, we scan the interior. We hit a 0 at index 1, 1. We flag its row and column. Look at the gold markers, we set matrix 1, 0, to 0, and matrix 0, 1, to 0. Next, we hit another 0 at index 2, 3. We flag its row at index 2, and its column at index 3. Now for the lockdown. We iterate through the interior again. For every cell, if its row or column marker is 0, we set the cell to 0. Watch as rows and columns vanish into zeros based on our flags. Finally, we handle our first row and column. Since our original flags were false, we leave them alone. And there it is, our matrix is updated in place with 0 extra space. Now let us look at the Python code. We get our dimensions m and n. We initialize our flags for the first row and column. We check if the first row has any zeros, then we do the same for the first column. Now the core logic. We loop through the rest of the matrix, from index 1 to m, and 1 to n. If matrix I, j, is 0, we use the first row and column as our scratchpad to store that information. In the second pass, we iterate again and set zeros based on those markers. Finally, we use our initial flags to handle the first row and column separately. This two-pass approach is the gold standard for in-place matrix problems. Looking at the complexity, time complexity is O of m times n, because we visit each cell exactly twice. Space complexity? O of 1. We used the matrix itself as our storage, achieving absolute efficiency. And that is set matrix zeros mastered. Save this video for your next technical interview, and follow Leo Academy for more such premium DSA guides.